Have you ever bought a computer with a massive 1 terabyte hard drive, thinking it would be super fast, only to find it lags when you have a few tabs open? It's a super common misconception, and today we're going to clear it up once and for all. Why doesn't a bigger hard drive automatically mean a faster computer? Stick around, because the answer might change how you look at your tech forever. Let's start with a simple analogy. Imagine your computer is a massive manufacturing operation. The goal is to produce things, whether that's editing a video, playing a game, or just browsing the web. At the heart of this operation is the factory workshop. This is your computer's CPU, or central processing unit. It's the brain, the powerhouse, the place where all the real work gets done. The CPU processes instructions at lightning speed, assembling data and churning out results. But here's the catch. The factory workshop itself doesn't store any raw materials. It needs them delivered, and it needs them fast. If it has to wait for materials, the entire production line grinds to a halt. This is what we feel as lag. So, where do these materials, this data, come from? This brings us to your giant 1 terabyte hard drive. In our analogy, think of this hard drive as a colossal remote warehouse. It's located way out in the countryside, miles away from the factory. Why is it so far away? Because the land out there is cheap, so you can afford a massive space. This warehouse can store an incredible amount of stuff, all your photos, videos, games, documents, your entire operating system, everything. It's got a huge capacity, which is fantastic for long-term storage, but there's a big problem. It's far away. Getting materials from this remote warehouse all the way to the factory workshop takes a lot of time. The roads are long and the trucks are slow. If your CPU, the factory, had to wait for every single piece of data to arrive from this remote warehouse, you'd be staring at a loading screen all day. It's just not efficient for day-to-day operations. This is where our next component comes in, RAM, or random access memory. In our analogy, RAM is like a small front-end warehouse located right next to the factory, on the docks. This dockside warehouse is much smaller than the remote one. You can't store everything here. You only keep the materials you need for the current jobs. But its biggest advantage is its location. It's literally a stone's throw from the factory workshop. When the CPU needs a piece of data, it can get it from this dockside warehouse almost instantly. The delivery time is incredibly short. So, when you open an application like a web browser or a photo editor, your computer doesn't run it directly from the slow remote hard drive. Instead, it sends a big shipment of all the necessary data from the remote warehouse, your hard drive, to the dockside warehouse, your RAM. Once the data is in RAM, the CPU can access it super quickly and get to work. This is why having more RAM often makes your computer feel snappier. It's like having a bigger dockside warehouse, allowing you to keep more projects and materials on hand, ready for the factory at a moment's notice. So let's recap the workflow. Your CPU is the factory, constantly working. Your hard drive is the huge but slow remote warehouse for long-term storage. And your RAM is the small but super fast dockside warehouse for active tasks. When you turn on your computer or launch a program, the necessary data is loaded from the slow hard drive into the fast RAM. Then, the CPU pulls the data it needs from RAM to perform its calculations. This hierarchy of storage is fundamental to how all modern computers work. It's a clever trade-off. We use slow, cheap, high-capacity storage for things we don't need right now, and fast, expensive, low-capacity storage for things we do. It's the same reason you keep salt and pepper on your dining table instead of running to the supermarket every time you need to season your food. Proximity equals speed. Now you might be thinking, what about SSDs? Solid-state drives? Aren't they much faster than traditional hard drives? Absolutely. In our analogy, an SSD is like upgrading your remote warehouse. You've moved it a bit closer to the city, and you've replaced the old, slow trucks with a high-speed bullet train. The delivery time from this new warehouse to your dockside RAM is dramatically reduced. This is why upgrading from a traditional hard drive, an HDD, to an SSD is one of the most noticeable upgrades you can make. Your computer boots up faster, applications launch in a flash, and files transfer quicker. But even with a super-fast SD, the fundamental principle remains the same. It is still the remote warehouse. It's still significantly slower than RAM. The CPU will always prefer to get its data from the dockside warehouse. The RAM, because it's the absolute closest and fastest source available. The hierarchy doesn't disappear. The first step just gets a massive speed boost. So, having a 1 terabyte hard drive just means you have a giant remote warehouse. It tells you nothing about the size or speed of your crucial Dockside Warehouse, the RAM, or how powerful your factory, the CPU, is. A computer with a small SSD and a good amount of RAM will feel much faster for everyday tasks than a computer with a massive traditional hard drive and very little RAM. The size of your long-term storage is about capacity, not performance. Performance is all about how quickly data can move between these different layers to keep the CPU fed and happy. It's about the speed of the whole supply chain, not just the size of the biggest warehouse. This brings us to a very interesting question. We know RAM is a small, temporary warehouse. What happens when you try to do too many things at once and it gets completely full? What if you open dozens of browser tabs, a video editor, a music player, and a game all at the same time, and your Dockside Warehouse runs out of space? Where does the computer put the extra stuff it needs to work on? The answer to this is a process called swapping, or using virtual memory. And it's the secret reason your computer suddenly slows to a crawl when you push it too hard. It's like the system has an emergency plan, but it's a messy one. We'll dive deep into exactly how that works and what you can do about it in our next video. So, I hope this analogy of the factory and the warehouses helps you understand why a big hard drive doesn't equal a fast computer. It's all about the balance and speed of the entire system. If you found this explanation helpful, please hit that like button and consider subscribing for more tech deep dives. Let me know in the comments if you've ever been confused by this, or what other tech myths you'd like me to bust. Thanks for watching, and I'll see you in the next one, where we explore what happens when you run out of RAM.